Greetings, this is lesson 11.3b, areas of regular polygons, and 11.5. I'm going to skip finding the area of a regular triangle, known as an equilateral triangle with side length 15.5. I will show you how to do it, so if you want to pause this video and you can try it, the answer is coming up very soon. We have equilateral triangle, side 15.5, angle 60 degrees. That gives us a 30, 60, 90 triangle. We could fill in the blanks with our patterns that we know. So we have 7.75 times the square root of 3. And to find the area, we do 1/2 base times height. 1/2 the base is 15.5, and the height is 7.75 root 3. And you can get the answer on your calculator. Moving on to the actual lesson. The lesson is about probability, geometric probability. The chance that an event will happen is probability. Probabilities should be between 0 and 1, inclusive, meaning it can be 0 or 1. So if you get an answer of 17, you are incorrect. The probability needs to be a decimal point between 0 and 1. So an example of geometric probability, find the probability of a point in the rectangle. You can read this yourself. Basic idea, we want to find the area of the shaded region divided by the area of the total region. In this case, the total region is the biggest shape you have, which is a rectangle. So we need to find the area of the rectangle, subtract the circle from that area, and then divide by the total area. So that's going to look something like this. Area of the rectangle is 25 times 10 minus the area of the circle. Notice the circle has radius 5. Pi r squared, r is 5, divided by, and this is where the probability comes in, divided by the whole region, 25 times 10, which is 250. And the answer you should get, if I remember from class, is right around 0.686 probability. There are no units on probability. It's 68.6% chance that you will pick a random point in the rectangle that hits the blue region. Now let's check out the next question. One like this, we need the area of the shaded region. Notice that the area, or the angle the angle here would be 360 minus 170, sounds like 190 degrees. So to find the area of the shaded region, we're going to go 190 divided by 360. Times the area of the whole thing. This is the area of a sector. Area of the whole circle, we have radius of 2. So we have pi r squared, so times 2 squared. But it's a probability. Notice right here it says probability. So we're going to divide by the area of the whole object. The whole object is a circle, which we just found, pi r squared. And actually, a bunch of stuff cancels out, which is really nice. You could multiply it all out, but the pi's are going to divide out. 4 and 4 divide out. So the answer is whatever 190 over 36 is, 19 over 36. If I remember from class, that is approximately 0.52 probability. Moving on. You could pause the video and do the try this if you'd like. Pause the video now. You can show me that later in class. The last half of the lesson is about areas of regular polygons. Really important that you get the vocabulary for regular polygons. So a center, you should know what a center is from a circle. Same idea, center of a circle, same idea as center of a polygon. All these polygons will be regular polygons. Hopefully you remember regular means all the sides are congruent, all the angles, interior angles are congruent. Radius is the segment that connects the center to the vertex. The apothem is the new term you might not have heard before. Apothem sounds like a possum. But apothem, that is the perpendicular distance. Perpendicular distance. You could try the next two. Draw a center, radius, and apothem for the following. Pause the video if you'd like to try to do that. The answer's coming up. And there are the answers. Sorry, that's not the prettiest thing, but it is a quick video tutorial, isn't it? Okay, for one like this, we have a regular pentagon. So we can draw in the given information. You have the apothem is 8.1. You have one side is 11.8. 11.8 is the whole side, even though I drew it way over there. So what you can do is find the area of this triangle, which you already have the base and you already have the height, which is very convenient. You would then have 1/2 base times height, 1/2 the base times the height. Doesn't matter the order you multiply, commutative property of multiplication. You can multiply in any order. Now that area is going to give you all of this in here. However, we want to find the whole area of the pentagon, right? And it's a regular pentagon. All regular polygons are divided into congruent triangles. So this pentagon has 5 congruent triangles. 1, 2, 3, 4, 5. So we're going to multiply here by 5 triangles. 5 triangles. So if I were to estimate, since I don't have a calculator handy, we have 1/2 times 12 times 8 times 5. This is 40. Half of 40 is 20. 12 times 20. So the answer is somewhere, this is an approximate, very rough answer, approximately 240 square centimeters. The next question is pretty similar to it. Just a regular decagon. So if you want to try to draw your own decagon, you can do that. But again, remember to find the area of a triangle. So the area of a triangle that you're finding, you're given the apothem length here, you're given the side here, and this is the triangle that you'll be finding. Area of that triangle right there. And once you have that, since a decagon has 10 sides, you're going to have the area of one triangle. Ooh, can't read that very well, can you? Times 10 triangles, and that will give you the area. I'm not going to finish that, just to keep this video short. And the last one is the trickiest one. We have the area of a regular hexagon whose radius is 10. The radius is given. So the radius, if you remember, is a segment from the center to the vertex, given as 10. You have the other radius that you could draw, and that's also 10. And what's neat about hexagons is that they are divided into a hexagon. You have six congruent triangles, and you have these 6 angles. If you can really see that, that's kind of vague there. 6 congruent angles. If you can see that, 6 congruent angles add up to 360 for that central angle divided by 6 of them. So you get 60 degrees. So you have a 30, 60, 90 triangle here. Here's 60. If you draw in your apothem that you need, this whole side's 10, it's equilateral. And this little part right there is 30, this little part right here is 30, and this is 60. So you can use your 30, 60, 90 pattern to determine the apothem. And once you have the apothem, you use the area of the triangle times how many triangles you have, and you have 6 of them. Hope this video is helpful.